Hello, dear listeners. I am Mehmetcan Çelik. I am a student of the Department of Electrical and Electronics Engineering at İzmir Katip Çelebi University. Today, I will tell you about my joint project with Tescom company. The name of my project is Battery Charge and Health Evaluation for Defective UPS Batteries via Machine Learning Methods. I will talk about the content section on this page. I will give you information about the flow of the presentation. First of all, I will explain the introduction part. Then I will explain the methods used in the creation of the project in the results section. I will talk about the outputs of the study. Finally, I will end my presentation with the conclusion part. The development of technology has caused data to occupy an important place today. This incremental data storage inspires new projects with artificial intelligence. The concept of machine learning, which is a sub-branch of artificial intelligence, develops the concept of data and can perform operations on the concept of data in the different areas such as classification, estimation, and clustering. The fact that data and machine learning concepts serve different areas has led to the formation of various innovations. These two interconnected concepts have formed the idea for realization of a study of UPS that have a significant impact in the field of electricity. In figure 1, we can see an UPS image manufactured by Tescom. UPS is an electronic device that contains battery groups used in health, military, and industry, which prevents the main supply of any electronic device from being cut off. Thanks to UPS, energy is provided in critical place where electricity should never be cut off. UPS, which are critically important in electrical energy, can be made more up-to-date by predicting problems that may occur due to the integration of battery monitoring system into a constantly monitored system. In figure 2, there is a 12-volt 9-ampere battery that is located in UPS and will be used in this project. In the targeted project, estimations of state of charge, state of health, and remaining time for discharge will be made for lead-acid battery. So, we aim to develop battery monitoring system for UPS. The steps to be followed can be summarized as follows. First of all, data collection circuit design was made. In the design circuit, there is a voltage regulator that primarily serves to fix the 12-volt value with a 5-volt value. 4 relays were used in our circuit. The first relay is used to activate our circuit. Our second relay decides the charge-discharge state. Our third relay allows the discharge process to be performed over 2 different loads. The voltage regulator located before the third and fourth relays ensures that the discharge process is constant at a value of 9.5 volt. We can see the inputs on the right side. The voltage value of the battery can be monitored with the voltage divider and op-amp circuit located on the left side. Current value of the battery can be monitored together with the current sensor connection located between the first relay and the second relay. These received values will be transferred to the Orange Pi 0 via Raspberry Pi Pico. In our circuit, which was realized in real life, LEDs were placed to understand that it was active and what function it performed. If you look at the image on the left side, our circuit is in a charging state because only the first LED is on. With the activation of the second relay, it switches to the discharge state. When we look at the circuit located on the right side, the second and third relays are active, thus our circuit is discharged. The image shows the environment used for the development of the project. There are 2 power supplies in the image. On the other hand, the discharge process takes place over the loads placed on the coolant. If you look at the state of our LEDs in the circuit, it seems that our circuit is discharged. Then the circuit design was made for the PCB drawing of the design circuit. With the design card, the status of the batteries in the UPS can be monitored. You can see the PCB card on this slide. And these are our machine learning regression methods. In the study, machine learning regression methods were used for state of charge estimation. Root mean square error, mean absolute error, and R-score performance metrics were used to test accuracy of machine learning regression methods. Each performance metric was calculated separately for charge and discharge status. Firstly, if we compare the performance metrics of the charging state, we can see that the most accurate result is obtained in the extreme gradient boosting regression algorithm in figure 11. We can see a graphical comparison of performance metrics of the state of charge in figure 12. Then, when we compare the performance metrics of the discharge state, we can see that the most accurate result is obtained in the extreme gradient boosting regression algorithm. When we look at the figure 14, we can see the comparison of performance metrics in the graph. Figure 15 shows the graph of the battery health status. In order to observe the battery health, it was charged, discharged 12 times in total. The battery was charged at 14 volt 1 ampere, 14 volt 1.5 ampere, and 14 volt 2 ampere. Discharge processes were discharged at 9.5 volt and 2.5 ampere. When the graph was examined separately for each discharge situation, it was observed that the charge-discharge times were close. The voltage value and time of the battery at any given moment can be estimated using the extreme gradient boosting regression method, which gives the most accurate result among the regression methods. We can this result in figure 16. The remaining time for discharge can be found using the voltage value and the time value corresponding to the voltage value. Moreover, the remaining time for discharge was determined using the total time known for discharge and the time value corresponding to the voltage value. And finally, in the conclusion part, in this study, a dataset was collected for state of charge, state of health, and remaining discharge time for estimation of UPS battery within TESCOM, and the regression methods of the collected dataset were analyzed. Root mean square error, mean absolute error, and R-score values were used to compare the regression models used. According to the performance metrics used, it was seen that the most accurate result was given in the extreme gradient boosting regression algorithm. When the collected dataset and regression methods were examined, it was realized that new studies could be carried out with the collected datasets of batteries in different environments or parameters. And thank you for listening to me. I wish you healthy days.